The name's Bond. James Bond. Welcome, Physics World. My name is Alexis O'Connell, and today we're going to be working on a projectile motion example. In this question, we're acting as a consultant for a James Bond movie set, and we are trying to figure out what velocity that a projectile has to be expelled from a cannon to reach the enemy territory above 75 meters above the cannon, and if it's 350 meters away horizontally. So we're going to work out how to solve this problem using the kinematic equations. And we're supposed to not assume that it hits the enemy territory at the highest point. So we cannot assume in this example that the velocity at the top is in the x direction is 0. So first what we're going to do is assess what we know. Well, we know that we're trying to find the initial velocity in meters per second, and we're not given that. So we see what else we have. Are we given time? No. Are we given the initial velocity in the x direction? Well, we know the x component is, and we know the angle. And so we could say that, because cosine is adjacent over hypotenuse, and the hypotenuse is the initial velocity, we could say that the velocity in the x direction is vi cosine 40, and the velocity in the y direction is vi sine 40. And we know the acceleration in the y direction is negative 9.8 meters per second squared, which is gravity. And because it's a projectile, the only acceleration is in the y direction. There is no other acceleration because it's in free fall. And we know we're given the displacements for the x and y components. So we're going to start with the x component of motion, because we know that we could just say that we know that there's no acceleration in the x direction. There's only acceleration in the y direction. So we know that if we use this kinematic equation, x final equals x initial plus vixt plus 1/2 at squared, we know that this whole value right here is going to turn out to be 0. And if we look at our problem again, we know that the initial x position is 0 as well. So it makes our formula for this a lot shorter, and we get this at the end. But wait, we have two values that we don't know. We don't know the initial velocity. We know the component of the initial velocity, but we don't actually know vi. And we don't know time. So what do? Well, I wrote here that when you have two variables, you need to solve for one and substitute it into another equation. And because time connects the x and y, we can solve for time and use that to equal the time in the other formula, and that will connect the x motion and the y motion together. So we know that x equals 456.9 divided by the initial velocity. And we just found that by plugging this into the calculator. So when we are trying to find the y motion, we are going to use the same exact kinematic equation, but for the y component. But in this case, the acceleration is not 0. It's the magnitude and direction of gravity. So we're going to do negative 9.8 for here. So if we just plug in what we know the initial displacement in the y direction is 0 because it wants us to start at the height that the cannon shoots the projectile, and that's all. That's 0. So we just plug in what we know, plug and chug, And we find that we don't even have to use the kinematic equation for this projectile motion problem. Because what we thought we were going to have, more than one place for VI, which if you do, you probably are going to have to use the kinematic equation. So if you end up with like a squared, and then plus bx plus y, then you're going to have to use a kinematic equation. That didn't make any sense. But, in this case, we're not going to have to use the kinematic equation. Maybe we'll solve that for another example in the future. And I'll explain that better then. But, so in this case, this velocity and this velocity are going to cancel out because they're divided by each other. And then you only have one variable that you don't know. And then you just solve for VI, and it takes a little bit of work, but you just plug in the calculator and you come out with this value, 68.397 meters per second. And that is how fast projectile must travel in order to hit the enemy territory in the movie James Bond. Thank you.